What if everything we thought we knew about the Earth beneath our feet was incomplete? Imagine a seismic wave, a silent tremor, rippling not just through the ground, but through our very understanding of the planet. For decades, we've learned the familiar textbook model: crust, mantle, outer core, inner core. Simple, elegant, and possibly wrong. Today we're diving deep into one of the most exciting mysteries in modern geology, the whisper of a lost layer, hidden deep within our world. This isn't science fiction. This is cutting-edge science, born from perplexing anomalies in data gathered from the most powerful earthquakes. Seismologists, the detectives of the deep Earth, are picking up signals that just don't fit our current models. It's like listening to a familiar song and suddenly hearing a new, unexpected instrument playing a haunting melody. These anomalies are forcing a radical reevaluation of the Earth's interior, suggesting there might be something more, a hidden chapter in our planet's story, tucked away hundreds of kilometers below the surface. So, how do we even know what's down there? We can't exactly drill to the center of the Earth. Our deepest borehole barely scratches the crust. Our knowledge comes from listening. When an earthquake happens, it sends seismic waves vibrating through the entire planet. Think of it like a planetary-scale ultrasound. By tracking how these waves speed up, slow down, bend, and reflect, scientists can map out the different layers. It's how we first discovered the boundary between the rocky mantle and the liquid outer core. For years, this method gave us a clear, consistent picture. But now that picture is getting fuzzy. New, more sensitive instruments are detecting faint echoes and strange diversions, particularly from a region deep within the mantle, that have left scientists scratching their heads. The area in question is known as the D layer, or the core-mantle boundary. It's a vast, mysterious zone where the hot, molten iron of the outer core meets the solid, yet slowly flowing rock of the lower mantle. For a long time, it was seen as a relatively simple transition, but the new data paints a far more complex and dramatic picture. It suggests this boundary isn't a clean line, but a sprawling, varied landscape. Imagine vast mountains taller than Everest and canyons deeper than the Marianas Trench, all made of strange, ultra-pressurized materials. And within this chaotic region, scientists have identified something truly puzzling: ultra-low velocity zones, or ULVZs. These are continent-sized blobs, sometimes hundreds of kilometers thick, where seismic waves slow down dramatically. What are they? That's the billion-dollar question. One leading theory is that they are remnants of ancient oceanic crust. For billions of years, the process of plate tectonics has been dragging the ocean floor down into the mantle in a process called subduction. Most of it gets recycled, but perhaps some of the oldest, densest pieces have sunk all the way to the bottom, accumulating over eons like sediment at the bottom of a lake. Another, even more mind-bending theory connects these blobs to the very birth of our planet. Remember Theia? The Mars-sized protoplanet that scientists believe collided with the early Earth about 4.5 billion years ago. That cataclysmic impact is thought to have thrown off the debris that formed our moon. But what happened to the rest of Theia? Some scientists propose that massive chunks of Theia's dense, iron-rich mantle plunged deep into Earth's own mantle, settling at the core-mantle boundary. If this is true, these ULVZs aren't just a geological feature. They are the buried remains of another world, hidden inside our own. This lost layer would be an alien graveyard, a planetary fossil from the dawn of the solar system. These aren't just abstract ideas. The presence of such a layer would have profound implications. The core-mantle boundary is the engine room of our planet. The heat flowing from the core into the mantle drives convection currents, the slow churning of rock that moves continents, builds mountains, and causes earthquakes. These strange blobs, these ULVZs, could be dramatically influencing this process. They might act as anchors, affecting the flow of heat and material, and could even be the origin point for mantle plumes, massive upwellings of hot rock that create volcanic hotspots like Hawaii and Iceland. Understanding this hidden layer isn't just about satisfying curiosity. It's about fundamentally understanding the forces that shape the surface we live on. To be clear, the existence of this Theian layer is still a hypothesis. The evidence is indirect, pieced together from faint seismic whispers. But the research is intensifying. Scientists are using supercomputers to model the ancient impact, trying to see if it could realistically result in these structures. They're deploying more sophisticated networks of seismometers to get a higher resolution picture of the deep Earth than ever before. Every major earthquake provides a new snapshot, another piece of the puzzle. It's a slow, painstaking process of elimination and discovery. We are at the very beginning of this journey, peering through a keyhole into a vast, unknown room. This quest to map the deep Earth is a testament to human ingenuity. We're using the planet's own vibrations to explore a place more inaccessible than the furthest star. The idea that we are still discovering fundamental aspects of our own homeworld is both humbling and incredibly exciting. We live on the thin, fragile skin of a dynamic and complex planet, and the secrets it holds are only just beginning to reveal themselves. What was once a simple four-layer diagram in a textbook is transforming into a complex evolving system with a dramatic hidden history. The whispers from the deep are getting louder, and scientists are listening intently, ready to rewrite the story of Earth itself. Thank you so much for joining me on this incredible journey to the center of the Earth. What do you think these mysterious blobs could be? Let me know your theories in the comments below. And if you enjoyed this deep dive into the mysteries of our planet, please don't forget to like this video and subscribe for more adventures into the unknown. See you next time.